Hey guys, sorry for the delay in getting these posted. I've had to work at my other job all day, so I'm back and we're going to do problems 25 through 27 in this video so that I can upload it. So let me turn on, the lamp's on, it's just dark in here at this point. Alright, so problem 25 said 3 over 2n equals 1 plus 1 over 4n. Ms. Woods is tired. It has been a long day. Bear with me. Alright, excluded values. N can't be 0 here, or n can't be 0 there. Put brackets around the whole thing. Find the least common denominator of 2n, an understood 1, and 4n. Well, that would be 4n, because they both have an n, and 2 and 4 both go into 4. Okay. Now we're going to multiply and reduce. 2n will go into 4n and will leave me with a 2. That 2 multiplies by that 3 to give me a 6. 1 will go into 4n and not cancel anything. 4n times 1 is 4n. 4n will go into 4n one time and cancel everything, so that 1 will multiply by that 1 to give me 1. So 6 equals 4n plus 1. I move the 1 to the other side, which makes it a negative 1, which gives me 5 equals 4n, and I divide both sides by 4, and I get n equals 5/4, which is not my excluded value, so my answer is 5/4. Okay. Problem 26. b squared plus 4b minus 5 divided by b squared plus 4b minus 12 equals b minus 4 over b minus 2 minus 1 over b plus 6. I had worked this whole problem out earlier this morning when I was doing this video and made a typo in the middle, so I don't know how yet to edit videos. I guess I should get Griffin to show me how to do that. So I have to start all over again. So this problem looks really familiar to me because I've already done it before. Alright, so the first thing I got to do is factor the bottom, and b squared plus 4b minus 12 factors to b plus 6b minus 2. That's what Ms. Woods calls a trinomial that starts with a square. Do not cancel those. I have students try. They're attached by pluses to a -5 and a -12. You cannot cancel them. If they were multiplied, you could, but they are subtracted, added and subtracted, so you cannot cancel them. Okay? So let's write our excluded values. B can't be -6. An excluded value is what makes it 0. B can't be +2. I put brackets around the whole thing, and I put my common denominator out in front, which is going to be b plus 6, b minus 2, because the b plus 6 will take care of these, and the b minus 2 will take care of those, and everything on the denominator will be taken care of. Okay? So what's going to happen? These two will cancel these two, and I'll be left with b squared plus 4b minus 5 equals. Here's where I made the typo last time. Let me see if I can do it correctly. This b minus 2 will cancel this b minus 2. Actually, it was a typo on problem 27. Never mind, it's not where I made the typo. This b minus 2 will cancel this b minus 2, and I'll have that b plus 6 will have to multiply by that b minus 4 minus that minus. This b plus 6 will cancel that b plus 6, so I'm going to have 1 times b minus 2. And I'm writing it that way so that you'll remember to distribute the negative all the way across. Okay? Now I'm going to distribute out and do some plain old algebra. B times b is b squared. b times -4 is -4b. 6 times b is +6b. 6 times negative 4 is negative 24. I FOILed. Negative 1 times b is negative b. Negative 1 times negative 2 is positive 2. Now let's do like terms. Negative 4b and 6b make 2b. Minus b leaves me with a b. Negative 24 and positive 2 leave me with negative 22. Now I've got to move things over. I notice I have a b squared on the left and a b squared on the right. They will cancel. Move this b over here, and that will give me 3b minus 5 equals negative 22. Add 5 to both sides. 3b equals negative 17. Divide by 3. b equals negative 17 over 3. That will not reduce. It's not an excluded value, so my answer is negative 17/3. Okay. Now to problem 27. Let's see if I can do it this time without making a mistake 3/4 of the way through. b plus 5 over b minus 4 equals b plus 2 over b minus 4 plus 1 over b squared plus 2b minus 24. Okay. First thing I've got to do is factor the denominators. Two numbers that multiply to give me 24 but subtract to give me 2 would be 6 and 4. And to get a positive 2, I have to have a positive 6 and a negative 4. My excluded values. B can't be 4 because 4 would make this denominator 0 and this denominator 0 and actually this denominator 0, and B can't be negative 6. Put brackets around the whole problem and put the common denominator out in front. My common denominator has to represent everything in the denominator. So it has to have a b minus 4 and it has to have a b plus 6. Here's where I made the mistake last time, so I'm going to try to be careful and not make the mistake. Last time when I copied it, I put a minus right there instead of a plus, and everything was wrong. Okay, this b minus 4 cancels that b minus 4. But the b plus 6 does not cancel. It has to multiply by the b plus 5. Equals. This b minus 4 cancels that b minus 4, but I have the b plus 2 times the b plus 6. The thing that doesn't cancel has to multiply by the numerator. Now on the last one, they both cancel. That's a plus. They both cancel, so it's just a 1. Now I'm going to FOIL. First, b squared, outer, 5b, inner, 6b, last, 30. FOIL again, outer, first, b squared, outer, 6b, inner, 2b, last, 12. And I would really desire for you guys to learn to do that in your head and not have to write it down, but I'm writing it down for all bits. Okay, 5b and 6b are like terms because they both have a b to the first power. 6b and 2b are like terms. 12 and 1 are like terms. Now I notice that I have a b squared on the left and a b squared on the right. If I subtract b squared from the left and I subtract b squared from the right, and I know I said those backwards as I did them, they'll cancel. Move the 8b, move the 8b, 3b plus 30 equals 13. Subtract the 30. 3b equals negative 17. What a coincidence. The answer to this problem is negative 17/3, just like the last one. And I let the computer generate these problems, so that's kind of funny that it generated two side by side that both were negative 17/3. The answer to 27 is negative 17 thirds, and that finishes this batch of 3.